Chapter 5, Laws of Motion. Yes. In last lecture, we have discussed what is force, types of force, okay, and then what is Aristotle's fallacy. When object is in uniform motion, moving with constant velocity, is there required any external force? Yes or no? If yes, then why it is required? Yes. During uniform motion, external force is required to continue its uniform motion to overcome frictional forces. Okay, if these two forces cancel each other, net force becomes zero, acceleration zero, and object moves with constant velocity. So yes, it was conclusion. Clear about this? Okay. Now, what is the law of inertia? What is the law of inertia? Galileo studied motion of objects on inclined plane. Okay. Now, first of all, we are taking two cases, and they are easy to understand. See, it is on inclined plane. Object is moving in downward direction. See, moving down an inclined plane. Yes, you know, if you draw or if you make this object free, if you draw, okay, this object from this point, yes, it will move in downward direction. Yes or no? And if you have observed its velocity increases, means it performs accelerated motion. It performs accelerated motion. Clear about this? Okay. Second case, if object is moving upward on slope, then yes, speed decreases. Speed decreases means it is case of retardation. Yes, whenever you are moving on some hilly area, okay, so yes, you have observed these two types of motion. Okay, whenever you are moving on inclined plane in downward direction, okay, speed increases, but when you are moving in upward direction, speed decreases. So yes, it is case of acceleration, it is case of retardation. Clear about this? Now, it is one slope, moving downward slope, moving upward. Now, if I take horizontal surface, means that intermediate stage means slope in downward direction, slope in upward direction. But if there is no slope, means moving on horizontal plane as intermediate situation like this, then in case it is acceleration, in this case it is retardation. So in this case, no acceleration, no retardation. Means object is moving with uniform velocity. Okay, so he concluded that object moving on frictionless horizontal surface, yes, frictionless horizontal surface, must neither have acceleration nor retardation. It should move with constant velocity when frictionless horizontal surface. Okay, if I am taking that intermediate situation, that is on horizontal surface, and on this horizontal surface, frictionless horizontal surface, if there are no external forces, then acceleration will become zero and object will move with constant velocity. Clear about this? Okay, so yes, Galileo's study of motion of objects on inclined plane. Another experiment performed by Galileo, double inclined plane experiment. What is experiment and what is result? See, first case, yes, we have two inclined planes, 1 and 2. If I release one ball from this point, then yes, you know that this ball will move in this direction, this ball will move, and it will reach to second plane at nearly same height. Why I am saying nearly same height? In practice, there is frictional forces present. Okay, in practice, frictional forces are present. So due to friction, some energy is used. So it will reach to nearly same height. But if I am taking idealized condition, means no friction present, friction is absent, then in that case these two heights are same. Final height is equal to initial height when friction is absent. Clear? So yes, it is one experiment performed by Galileo, that is double inclined plane experiment. See what is, if the planes are smooth, smooth means no friction, the final height of ball is nearly same as the initial height. Ideal situation, when friction is absent, final height is same as initial stage. It is as initial state, and this thing is according to law of conservation of energy that we will discuss in chapter number 6. Clear about this? Okay. Second case, here these two planes have same slope. See, it's slope bending and this side bending, slope is same. Now if I change, if this side slope is decreased, see this side slope is more and here slope is less. So if slope is decreased, then what happens? If slope of second plane is decreased, the ball will still reach the same height, but it will travel a longer distance. Yes, this ball will travel a longer distance, and it will reach the same height. It will reach the same height. It is final height. It is final height. Again, this surface is smooth, frictionless. This surface is smooth, frictionless. Clear about this? Okay. So yes, from this to this point, the ball has to travel more distance. Clear about this? Now third case, if the slope is decreased, and it is reduced to 0, then what happens? See, when the slope of second plane is 0, then if I release this ball from this point, it is released, no external force, okay. If ball is released from this point, it is frictionless horizontal surface. Frictionless horizontal surface means no frictional force. Then obviously this ball will continue to move to infinite distance, because force acting on it is 0. Again, what is case number 3? If the slope of second plane is reduced to 0, here it is larger, reduced. Now here slope of second plane is reduced to 0. Then yes, it is released, means no force. Frictionless horizontal surface, no friction force. It will move to infinite distance. Okay, when the slope of second plane is 0, the ball travel an infinite distance. It is idealized situation. In practice, okay, yes, ball have to face some friction forces. Okay, and yes, due to that friction forces, after traveling some finite distance, it stops. And yes, to move it with uniform velocity, we have to apply some external force. Clear about this? So see, in practice, the ball does come to a stop after moving a finite distance on horizontal plane due to friction force. But if there were no friction, the ball will continue to move with constant velocity on the horizontal plane. Means this ball is moving with uniform velocity when there are no external forces. Clear about it? What is conclusion of this theory? See, if one object is in rest condition, then total external force acting on that object is, yes, it is 0. That's why it is stationary. In this case, this ball is moving with uniform velocity, and yes, here no external forces are acting on it. Yes, in first experiment, in third case, when ball is moving on horizontal plane with uniform velocity, no acceleration, no retardation, yes, it continues its motion because there is no friction force. So yes, when the total resultant external force is 0, we can say there are two types of states. First, rest condition, and another condition or state of uniform motion. So what is conclusion of theory? The state of rest and the state of uniform linear motion, means moving with uniform velocity, are equivalent, and in both cases no net force acting on body. No net force acting on body. If object is in rest condition, total force acting on it is 0. If object is in uniform motion, total external force acting on it is 0. Means these two states are equivalent. These two states are equivalent. So now in motion we have total 4 types of state. First, rest condition. What is force? 0. Okay. Second, uniform motion. Again, what is net force? 0. Third one is accelerated, and fourth one is retardation. Clear about this? Yes, in these two cases there is some net external force, but in case of state of rest and uniform motion there are no external forces. Clear about this? Yes, if there is no friction force, then object will continue to move to infinite distance. Yes or no? But if friction is present, then remember example of last lecture. Okay, to continue motion of cycle with uniform velocity, we have to apply pedals. Means we have to apply some external force to overcome friction. Yes, if external force cancels friction force, total force becomes 0. And yes, total force becomes 0 means that cycle moves with constant uniform velocity. So yes, to maintain a body in uniform motion, we need to apply an external force so that the two forces sum up to 0, net external force. When there is friction present. Okay, so what is conclusion of this whole theory? If the net external force is 0, a body at rest continues to remain at rest, and a body in motion continues to move with uniform motion. This property of the body is called inertia. Okay, if a body is stationary, then if I am not applying any external force, it will remain in state of rest condition. If one object is moving with uniform velocity, if I am not applying any force, it will be in state of uniform motion. Okay, and this property of body is called inertia. And inertia means resistance to change. Body is stationary. I am not applying any force. Means it is not moving. Resistance to change. If body is in motion, I am not applying any force. So yes, it will continue with uniform velocity. Resistance to change. So inertia means resistance to change. If I am not applying force, it will not change this two state. Clear about this? So yes, it is all about law of inertia. Okay, yes, these laws are governed by Galileo. Now, from the experiments of Galileo, Newton formulated some laws, and yes, they are called laws of motion. Newton gave 3 laws: first law, second law, and third one. Yes, these 3 laws are important to solve questions in mechanics. Okay, so what is Newton's first law of motion? That we will see. What is Newton's first law of motion? See, Newton's first law of motion. See, here it is. What is statement? Yes, statement is result of this law of inertia. Every body continues to in its state of rest or uniform motion in a straight line unless compelled by some external force to act otherwise. Means if force is not acting, stationary object will remain stationary, and object in motion will continue its motion with uniform speed. Clear about this? Okay. So from this we can say if body is at rest condition or uniform motion, acceleration is 0. Acceleration is 0 because net force acting on it is 0. So acceleration is 0. Okay, if the net external force on body is 0, acceleration is 0. Force 0, then acceleration 0. But if force is non-zero, then acceleration is also non-zero. Acceleration can be non-zero if there is a net external force on the body. So what is conclusion? If there is force, there is some acceleration. If there is some net external force, there is acceleration. There is acceleration. So acceleration is produced due to some net external force. Acceleration is produced due to some net external force. So yes, we can say it gives definition of force. Newton's first law of motion gives definition of force. Newton's first law of motion gives definition of force. Clear about this? Clear about this? So yes, it is Newton's first law of motion. You have to remember this statement, and yes, these 2 points. Clear? So yes, it is about Newton's first law of motion. Now in next lecture we will study what is linear momentum, what is Newton's second law of motion. And yes, Newton's second law of motion is very important topic. Dear students, watch video regularly of each and every subject. Like, share and comment on each video.